Okay, Algebra 2, here we go. We're going to graph some exponential growth and decay functions. And in order to do that, we're first going to just explore what they look like. So first we're going to explore the graph of y equals 3 to the x. So in order to do that, we're going to make a little xy chart here. So let's start with the easy ones here. Let's start with 1 and 2. So if we have y equals 3 to the, let's plug in 1 for x. Well, that's just going to be 3. So we get the point 1, 3. And if we plug in 2, we get y equals 3 to the 2. Well, that's 3 squared, which is 9. So we get 2, 9. Okay, how about 0? What if we have y equals 3 to the 0? Okay, hopefully you remember the rule there. Anything to the 0 power is 1. So we have the point 0, 1. And let's plug in a negative. What happens when we plug in a negative? We have y equals 3 to the negative 1. And of course, you know your rules of negative exponents means you flip that. So it's 1 over 3 to the positive 1, or just 1/3. So this is negative 1, 1/3. We don't have a 1/3 line there, so we just do a rough guess of where that is. Now let's plug in negative 2. So we have y equals 3 to the negative 2. Again, of course, a negative exponent flips. So this is 1 over 3 to the positive 2, which is 1/9. So we're going to go negative 2, 1/9. So let's think about what else this graph is doing. If we go to the right, when we get x equals 3, we'll have 3 to the 3rd, which is 27, which is way up there. 3 to the 4th, that's 81. That, of course, is way, way, way up there. So we can see here what's happening. We are growing very, 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 very quickly, which is why this is called exponential growth. What's happening to the left? Well, to the left here, we have 1/3. We have 1/9. When we plug in negative 3, we're going to get 1/27. When we plug in negative 4, we're going to get 1 over 81. So what this is doing is getting really, really, really close to the y-axis, or the x-axis, the y equals 0. But it's never going to actually cross it. It's never going to touch 0. It's never going to cross over and be negative. So we call this line that this graph is never touching. It's hard to see, but it's never, ever, ever going to touch that line. It's just going to get closer and closer to it, and that is called the asymptote. So this has an asymptote right here at y equals 0, because the graph over here gets closer and closer and closer to that. So why is this called exponential growth? Because it is growing up fast. It is going up fast. Okay, so let's look over here. This one, as I'm sure you've guessed, is going to be decay. So let's see what the graph does here. So let's plug in the easy ones. Let's plug in 1. So we have y equals 1/3 to the first power, which is going to be 1/3. So we're going to plot over 1 up 1/3. And now we're going to plug in 2. Y equals 1/3 to the second power. Going to be 1 to the second, 3 to the second, which will be 1/9. So you can see we're getting the same numbers, but in the opposite direction. And then hopefully you notice that if we keep continuing out, we'll end up with 3, 1 over 27, 4, 1 over 81, and we're doing the same thing here. That is getting closer and closer to the axis, but won't actually touch it. So we plug in 0. Anything to the 0 power is 1. What happens if we plug in a negative here? So we have 1/3 to the negative 1, which is going to be 1 to the negative 1 over 3 to the negative 1. Negative exponents, of course, flip. So we have 3 to the positive 1 over 1 to the positive 1, or just 3. So negative 1, 3. Same concept with negative 2. We're going to plug in negative 2. We get 1/3 to the negative 2, which is 1 to the negative 2, 3 to the negative 2. Flip them. You end up with 9 over 1. So we get the point negative 2, 9. Negative 3 would be 27. Negative 4 would be 81. So this is going this direction. So as you can see, this graph is dropping very quickly. Okay, so this is going down very fast, and that is why that is exponential decay. And it also has an asymptote at the line y equals 0. So we can draw in that asymptote here, which is where the graph is going to get really, really, really close to, but never touch. Okay, so how can we look at these and determine which one is growth and which one is decay? Well, it's very, very easy. We are looking at this number right here. If that number is bigger than 1, which this is, then it's growth. If it's less than 1, then it's decay. Has nothing to do with anything out in front of that. So if we look at number 3, all we're looking at is what's to the x power. We don't care about that negative. That's going to do something else. So this is growth because 3 is obviously bigger than 1. On number 4, all we're looking at is this right here, whatever's to the x power. That is less than 1, and therefore this is decay. Notice on number 3 and number 4, they both have a negative out front. We don't care about that. That's not the issue. Okay, that does something else. That's going to reflect it over the x-axis, just like it has on other graphs. So number 5, this will be growth, because 5 is bigger than 1. Number 6, we have 1/3, and this will be decay, because this is less than 1. So go ahead and pause now and on your own. Knock out numbers 7, 8, 9, and 10, and grab your graphing calculator, because we are going to do the rest of these graphs on the calculator. Okay, hopefully you got all those right. Real quickly, I'll go through them. Number 7 is growth because of the 3. 8 is decay because of the 1/3, less than 1. 9 is growth because of the 5, bigger than 1. And 10 is decay because of the 1/3, less than 1. So hopefully you got all those right. All right, so grab your graphing calculator, and we're going to enter in number 11. Okay, so number 11, in your calculator, you are going to go to y equals, so that you're here on this screen, and you're going to enter this in. So we want to enter in -2 divided by 3 times 5 to the, now if you have a calculator like mine and it brings it up as the exponent, you don't need parentheses. If you don't have that on your calculator, then you need the top in parentheses. You need that exponent in parentheses. So I'm going to put it in just so that everybody has that. So we're going to have x plus 2 in parentheses, and then a big plus 8. And then we're going to graph. So a couple things to remember about graphing. One is that if your axes are gone, go to Format, which is second Zoom. Turn your axes on. If your window's all messed up, you can go to Zoom Standard, which is Zoom 6, and it'll bring up this exact same -10 to 10 coordinate plane that I have. Okay, so we're going to look at that, and we're going to see what happened. Well, hopefully you know that this is growth. Okay, so we're going to go ahead and call this growth. Why is it growth? Well, that's because of the 5. The 5 is bigger than 1, and therefore it is growth. Is the graph reflected? Remember, reflected means it's flipped over the x-axis, and this is reflected over the x-axis, and that's because of the negative. Okay, that A out front, that A is negative, and therefore is the graph reflected? Yes, it is. Okay, so hopefully you can tell from the picture here that this is a exponential growth that's going up, and then it's flipped over. Okay, so that is exponential growth reflected over. All right, so where's that asymptote? Now, normally this asymptote is at y equals 0. However, it has been shifted up. And if you use, remember what you learned about shifts, you would know that it was at y equals 0, because that's where they start out at the beginning. They start out here at y equals 0. And anything you add on to the end is going to shift everything. And so this 8 is going to shift it up 8. Okay, so our graph, our asymptote is going up 8. So this is going to be at y equals 8 because that shifted it up 8. So we're going to go here at 8 and we're going to put our asymptote there. Okay, and then we need some more points. So we love our calculator, so we're going to use this. So let's do the easy one first. The easy one would be the y-intercept, where we go to second calc, and we go to value, which is 1. We want the y-intercept, which is where x equals 0. So we plug in x equals 0, and we get the point negative 8.7. So we're going to write in the point negative 8.7 for our y-intercept, 0, negative 8.7, and we're going to graph that. Zero, negative 8.7. And now we need our y-intercept, which are a little bit more difficult. So we go to second calc. Our x-intercept, sorry. We need our x-intercept, so we are going to go here. We're going to go to 0, which is number 2. And our x-intercept is right here. Okay, so to get that, we need to go left, right, center. Notice at the bottom it says left bound. So I'm the left of that point, I press enter. Now I'm going to scoot on over to the right of that point and press enter. And then I'm going to go right on top of that point, or as close as I can, and press enter. And I get the 0, or the x-intercept, as negative 0.5 comma 0. So I'm going to go back to my graph here, and I'm going to go x-intercept is negative 0.50, which is right here. Okay, and then I'm going to look at my picture again, and from my picture I'm going to draw this graph. You have to remember what an intercept does, or what an asymptote does, so I want to draw up into that and then get closer and closer and closer to it, but never touch it. Okay, so now my domain, because this is going obviously forever left, and this is going forever right, although very slowly, so the domain is all reals. The range, because we know this asymptote, means that the graph's never going to cross that. It's going to stay below 8 all the time. So the range is y is less than or equal to 8. Okay, so hopefully that is a good refresher on how to use your calculator. So what you're going to do now is you're going to do problem number 12 on your own, and we will go over it in class tomorrow. See you then.